Hey guys, how you doing? Welcome to the second part of the chain rule. In the last video we talked about the chain rule and how it can be used to solve derivative problems much more easier rather than having to FOIL multiply out functions. So let's go with our first example. Example number 1. Here we have the derivative, here we have the function and we want to find the derivative of the function. Now this is my inside function. Okay, so here's what I'm going to do. I'm going to apply the power rule because this whole function in the inside is being raised to the 5th power. So I'm going to drop the 5 like if it was a power rule. 5, keep the inside. Go back to the first video just to make sure that you guys know what I'm doing. We always keep the inside and then take the derivative of the inside the parentheses and multiply it to the outside, and that is 12x squared plus 3. So really I have 5 12x squared plus 3 4x cubed plus 3x minus 2 to the 4th, and I'm done. Way more easier rather than having to FOIL 5 times and then taking the derivative of each term. So let's go with our next example. So let me just give you guys a much more easier way of looking at the chain rule. I used to like to teach it like this. F of u, okay, u would represent the inside function, kind of like the product rule, u times v. I'm gonna say that this is my u. So let's do it like this. U is x to the 4th plus 2. Okay. Now, if I do the chain rule like this, if I use f of u, then the chain rule is the same as the one above. Let me just do this. F prime of u times u prime. That looks a lot more easier rather than having to see f and g together. So look at this. Here, this is my u up here, and this is my u prime. All I did was just label this u instead of g of x and that instead of g prime of x. Okay, so if you like that, you can do that method. It really doesn't matter, you still get the same answer. So what would u prime be? No, not 3. It would be 4x to the 3rd. So let's go ahead and figure out our derivative. I'm going to apply the power rule. Drop the 2/3. Keep u. Take 2/3. Oh, take 1 away from 2/3. So I'm going to do it over here on the side. 2/3 take away 1 is the same thing as 2/3 take away 3/3, which is negative 1/3. Negative 1/3, and then the chain rule. So times the u prime, which is 4x to the 3rd. Now we don't want to leave our fraction, we don't want to leave negative exponents. 2/3. I always like to write this in the front. 4x to the 3rd, and then this would be the same thing as the cube root of x to the 4th plus 2. So let's clean this up one more time. I'm going to multiply the 2 and the 4, and that becomes 8x cubed on top all over 3 cube root of x to the 4th plus 2. Now really this answer is acceptable, but on the AP test, if there was a multiple choice question, they would probably have this answer on there. All they want you, they're just trying to test to see if you know your negative exponents. Now the next example, we have another fraction function. Okay, except I'm not going to use quotient rule, because if you remember from the last videos of the quotient rule, if the numerator is a number, a constant, then simply rewrite this as negative 7. Notice that this is being raised to the 2nd on the bottom, so I'm going to bring up the denominator as negative 2. Now I have a chain rule problem. Drop the -2 to the front. So it's -2, -7, 2x minus 3, -2 take away 1, and then the derivative of the inside times 2. So this is going to be 2 times 2, -2, and -7, which is a total of positive 28. 2x to the 2x minus 3 to the -3rd, which is the same thing as 28 over 2x minus 3 to the 3rd power. Here's a tough one. Okay, I'm not trying to scare you guys, but this one looks pretty tough. So I don't have a number anymore. I have now a 5x over a cube root of x squared plus 2. So this one I have to use quotient rule. There's no other way around it. Quotient rule. Let's go ahead and review what quotient rule is. U over v, the derivative of u over v is v u prime plus, no, not plus, minus u v prime. Okay, so all over v squared. So this is my u, this is my v. So why don't I go ahead and just write everything to the side? When I used to tutor, I used to just have this, all my students that I tutor, write everything to the side. The cube root of x squared plus 2 is the same thing as x squared plus 2 to the 1/3. And then let's find out our derivative. U prime is 5 v prime. Well, that one's going to be a little bit tough. V prime is 1/3 x squared plus 2 to the -2/3. All I'm doing is taking away 1 away from the power, so it's -2/3, and then times the chain rule times the derivative of the inside, which is 2x. So let me clean up v prime. V prime is the same thing as 1/3 x squared. No, it is now 2/3 x, because I'm going to multiply these two together. 2/3 x times 1 over the cube root of x squared plus 2 squared. Okay, now the reason why I wrote it as the cube root and then the inside squared, because the top part says we square it in the bottom, and the bottom part of this fraction says we cube root. So let me go ahead and just clean this up one more time. So it's going to be 2/3, let me write it like this, 2x over the cube root of x squared plus 2, all of this squared, and that is my v. So I have 4 components: 5x, my v, and my v prime. So let's go ahead and figure out our derivative. Our derivative is v times u prime, so it's going to be v times u prime minus u times v prime, so it's going to be 5x times v prime, which is 2x all over 3 cube root of x squared plus 2 squared all over the bottom squared, so it's going to be 3 cube root of x squared plus 2 squared. Just to tell you guys this is the same thing as this. Okay, now I'm gonna go ahead and leave my answer like that because I'm running out of time. I want to challenge you guys. I want you guys to go ahead and try to rewrite this expression here. This is the derivative. I mean, this is the derivative. We technically found the derivative, but it's not all that clean. So I'm going to challenge you guys to complete that rest of the problem. Clean it up a little bit, see what you can do. I'll see you in the next video, and we'll talk about the parts below.